Okay, today we're looking at some more applications of linear programming, some of it a little bit more complicated. So here we go, dietitian in a local football team, two types of powdered food products for her team. The nutritional content, the two products per 250 grams are listed in the table below. So there they are. The team's minimum requirement of carbohydrates, fat and protein are 30 grams, so carbohydrates 30 grams, fat 4 grams, and protein 15 grams respectively. Product A costs 50 cents, product B costs 60 cents per 250. How much for the least cost? So there's our objective. Costs, least. Alright, so we've got our restrictions and our objective. So this one is a little bit more complicated in that it's not just straightforward to get that carbohydrate 30 grams of. There's two things that contribute to that. Okay, so let's have a look. What are our restrictions? So let's look at the carbohydrates to start with. So carbohydrates come from product A and product B. So I'm going to use A and B again. You can change it to X and Y should you wish to, but I'm not going to. Just A and B. So A is the amount of A in lots of 250 grams. Alright, so remember that 25 grams for product A of carbohydrates, that's 25 grams in each lot of 250. So if I take one lot of 250, I get 25 grams. So, and then B is the amount of B in lots of 250 grams. Alright, so looking at the carbohydrates to begin with, and I'll put these in their colours that I've underlined them in. So for the restrictions that we've got a maximum, minimum, these are minimums, sorry, minimum daily for these things. So we've got a minimum, so whatever, it's got to be greater or equal to 30. So for product A, in each 250 gram lot of that, we get 30 grams. Plus, in product, oops, got the wrong way around there, haven't I? 25 grams for product A, I need to read the table properly. Plus, from product B, that's we get 30 grams of that. Alright, and that's got to be at least, so greater or equal to 30. Alright, the fat one, so for product A, there's two, for each lot of 250 grams you get 2 grams of fat, and for product B, for each 250 grams you get 4 grams, and its minimum amount that you need in the day is 4 grams. Then for our protein, well, for each 250 gram lot of product A you get 15 grams. Looks like 16, not 15. 15 grams. And for each 250 gram lot of product B you get 10 grams, and the minimum we want, so we want more, is 15 grams in total. Alright, so there's our restrictions, so you graph those on the graph, find your corner points and test your corner points. And what are our corner points testing for? Well, they're testing for our cost, and so the cost is equal to the amount of product A that you get times by what its cost is, 50 cents, so 0.5, let's work it in dollars, plus the cost of B, and B costs you 60 cents, so 0.6, so there's our objective function, which in this case we're looking for the minimum, because we want the minimum cost. Alright, all the other exercises, you've done all this graphing stuff, so if you don't know how to do that now, by now, you should have spoken to me well before now. So I'm not going to graph it and do that for you. So these ones, you've got to be a little bit more careful, and you've got to read the questions a little bit more carefully to pick out the bits that you need. Alright, so that's question set number 6, exercise 11F. And the next lot's revision and then test after that.